The Gravitation for Dummies. Act 1. To fill the play a little, let me start with a bit of history. The fall of bodies has always fascinated men. The first attempt at explanation was given by Aristotle. Solid bodies fall. Behind the falling bodies there would be a principle, an essence, a basic element which he called earth. The nature of this element is to go down. He knew that the earth is round because of the circular shape of the shadow cast by the earth on the moon during eclipses. If everything falls towards the earth, everything necessarily falls towards its center, which is therefore the center of the world. The stars of heaven do not fall because they are not made of earth but of ether. Ether is the matter of the sky and it has circular motion by nature. The resistance of the air would disturb Aristotle. A stone falls much faster than a feather, so the heavier the body the faster it falls and the speed increases when falling, so the weight increases in the fall. The discovery of his push by Archimedes changed nothing in this system. The explanation of Aristotle by motions which would be natural to things remained the only one until Galileo Galilei. During this long period, the gravitation was abandoned and the problem of the movement of bodies was exclusively dealt with, for example, the motions of Achilles and the tortoise in the famous paradox of Zenon. Around the year 500, in Alexandria, the astronomer Jean Philippon had the intuition of the notions of momentum and inertia. He called impetus the cause of the motion. It passes from one body to another during a shock, for example. Afterwards, the impetus was hastened into Aristotle's natural motions so that nothing would change. Act 2. The very famous experiment of the Tower of Pisa was going to ruin definitively Aristotle's theory. Galileo showed that all bodies fall at the same speed. Obviously this observation is not very spectacular and we especially remember the discovery by Galileo of the satellites of Jupiter. Jupiter is the center of the world. There are center of the world everywhere, so no center of the world at all. Back to square one. Gravitation remains without any explanation. Descartes proposed the first physical explanation of gravitation. He assumed that the stars are surrounded by swirls in a fluid filling space. Incidentally, this fluid carries light, a wave like the waves of the sea, and sound in the air. But first it is primarily the cause of gravitation. Descartes called on the phenomenon now called the gyrocyclone effect. You can reproduce it in your cup of tea. Spin the tea with your spoon then let the motion continue by its own. You will see the small lumps of tea that the strainer has not stopped gathering in the center at the bottom of the cup, even if the bottom is bulging upwards. The lumps continue to turn. This gyrocyclone effect is opposed to the centrifugal acceleration of the stars in rotation around the Sun, for example. The problem with Descartes' theory is that it does not allow for calculations. This is a purely qualitative explanation. Now, the discovery of differential calculus by Newton, then by Leibniz, was to precipitate science into an excessive mathematization. Act 3. Newton postulated that bodies attract each other in proportion to their mass and in inverse proportion to the square of the distance between them. Everything was so consistent with observations that the Cartesians, unable to find this relationship through their swirls, were soon forgotten. It is very surprising that Newton accused Descartes of not having considered the action of centrifugal acceleration when this was his great concern. In Descartes' system, this acceleration is opposed to vortex accretion. On the other hand, one can think that Newton could not accept that this accretion could be the cause of the fall of the bodies. The vortex accretion is axially symmetrical. It cannot explain the fall of the bodies outside the swirl. Newton proposed the physical explanation for gravitation at the end of his optics treatise. Space would be filled with an ether that is denser as we go away from matter. The gravitation would result from the variation of the density, so that the push of Archimedes would have pushed the bodies towards the least dense parts of the ether. However, Archimedes' push results from gravitation. In no case can it be the cause of gravitation. Newton first mentioned another physical explanation for gravitation: condensation in the bodies of a fluid filling space. Act 4. Huygens was completely against the Newton's idea of attraction, but he was interested in his attempt to explain gravitation by interactions between matter and ether, the fluid that fills space. He shared it with his friend the Swiss Nicolas Fatio de Dillier. The latter presented to the Royal Society of London in 1688 his theory based on a screen effect. This approach was taken up by Georges Louis Lesage, who gave it its name. Lesage proposed in 1748 a theory of gravitation directly inspired by that of Fatio de Dillier. The attraction between two bodies would result from a screen effect of these bodies with regard to corpuscles which would fill space. If all the nuclei of the atoms had been, initially, gathered in a compact mass divided and then distributed in space, there would be a relative vacuum between the nuclei. The mean free path of the corpuscles of ether should always have been greater than the mean distance between the nuclei. This statistical condition is unrealistic for the nuclei of atoms located at stellar distances. For the action of the ether to be proportional to the mass of the bodies, the corpuscles must act inside the matter itself. Lesage therefore assumed that matter is made up of very small elements. Between these elements, his corpuscles move freely. The atom theory was to prove him right 150 years later. Riemann resumed in 1853 Newton's attempt to explain the gravitation by condensation of a fluid filling space. He thought that this fluid was evacuated into another universe through a sort of black hole. Ivan Osipovich Yarkovsky took up this idea in 1888. But, he thought that ether condenses in matter. He was led to imagine a progressive increase in the mass of bodies. This hypothesis incidentally implies an expansion of the stars. These attempts all came up against the problem of the composition of the speeds of the stars. If a fluid pushes the bodies towards each other, a motion in the fluid necessarily causes a drag. This drag is irreconcilable with Kepler's laws. Act 5. Around 1900, Hendrik Lorentz tried, unsuccessfully, to use Lesage's theory to explain the gravitational attraction of two electrons and thus to explain gravitation. Many scientists are still trying to use screen effect to explain gravitation. Various hypotheses have been put forward to solve the problem of the drag of bodies moving in ether. The Magnus effect can only be used if the body is rotating. These explanations of gravitation by physical models do not fit into the dictates of the great progressive movement. Mathematical equations, only mathematical equations. But what relief for our progressives when in 1915 Albert Einstein was able to develop, with his team of mathematicians, the equation of the gravitational field. The general relativity theory explains the Mercury anomaly and the deflection of light by the sun. It's marvelous. In the process, the relativists plan to bring all the forces of nature into a single law, obviously mathematical. This is the culmination of the positivist project of our progressives. The end of science. But a first shadow is looming. That the anomaly of Phobos, a satellite of Mars, remains unexplained. It does not matter. But the stars of the galaxies do not rotate according to the laws of Kepler. Their speed is roughly independent of their distance from the eye of their galaxy. Relativists invented dark matter. It remains absolutely undetectable. And yet, a dreadful drama arises from elsewhere. General relativity roams the infinitely large universe of galaxies. It's the infinitely small that shakes everything up. Everything is quantified. Quantum mechanics is hitting relativist optimism head-on. Relativists are convinced that the very phenomenon of gravitation is a curvature of space-time. The gravitational field equation is therefore much more than the simple formulation of the phenomenon. It expresses the reality of the phenomenon itself. The curvature of space-time, as the mathematical equations are continuous by nature. String theory has failed to reconcile the contradiction between this continuous vision and quantification. Science remains suspended to this insurmountable paradox. And gravitation ultimately remains without explanation.